Alrighty, folks, we're looking at question number 8 on your practice final. It says, which of the following functions does not have a domain of negative infinity to infinity? So we're going to first, so we want what it does not in domain. These are the, if we recall, these are the x values of a function that are allowed. Okay? Oops, sorry. So these are the x values of a function that are allowed. So if we recall, the only really functions we have to worry about were our radical functions. So in this case, a square root, and also we have rational functions. Rational functions are fractional functions. In particular, we have to worry about for radicals, whatever is inside, has to be greater than or equal to 0. And with radicals, the denominator, we know that we have to watch out for what makes the denominator 0 too. So these are the two things that we need to be concerned about. So when we look at our problem here, we just need to figure out where that is. Okay, and the easiest thing to do is, number one, is to do a sketch of each graph just to see what you have here, right? And then, so sine we know looks like this here in S, and it continues to go on. Okay, so this clearly, if you move from left to right, has a domain from negative infinity to infinity. So that does. Cosine also does. Cosine starts at the top at 1. It goes down to negative 1 and kind of does this here. So very similar to sine, shifted over by pi over 2. And again, the arrows indicate here that from left to right, there's no holes, breaks, or asymptotes, right? So that's what we're looking for. So cosine is also safe. Tangent, the graph of tangent, if we remember here, there's two ways we can think of it. We can graph it out here, and we have vertical asymptotes at pi over 2, negative pi over 2, right? And there's another one at 3 pi over 2, and at negative 3 pi over 2, and we graph out tangent, and as you can see here, as you move from left to right, I have to stop, I move forward, and I stop, and I move forward, and I stop, move forward and stop. So if you can see, this actually has vertical asymptotes. It has an infinite number of vertical asymptotes at x equals pi over 2 plus pi k, where k is an integer. So basically this means that if you add another pi, you get another vertical asymptote. This is just to simply say there's a lot of these vertical asymptotes. There's an infinite number. So that means that there's an infinite number of unions, right? Because it would be, the domain would be from here to here, union here to here, union here to here, here to here, etc. So tangent definitely does not have one. Secant also does not have one. Why? Because secant, as we know, is 1 over cosine of x. And so it looks like a fractional function, or like what we're talking about, a rational, right? And so we have to find where cosine is 0. And if we were to graph out secant, we would first graph out cosine, right? Cosine looks like this here. And then we draw the reciprocal, or the reverse image of that. And then this is our secant function here. And then secant has vertical asymptotes as well, just like tangent. So this is another function that does not have domain of negative infinity to infinity. So there's two ways you can look at this problem. You can either graph them out, okay, or if you don't know what the graph looks like, write the equation out. See, you have a rational, so that means you need to know, well, it's not really a rational, but you have a function that's in the denominator where an x value could be 0. And so that means that it's not going to be continuous everywhere. Also with tangent is also sine over cosine, and then sine is fine, but again, cosine, it's possible for that to be 0. So that means that both of them do not have a domain from negative infinity to infinity, so the answer must be E.